form a clinical picture that's distinct from Rett syndrome. At the moment, phenotype, genotype, so clinical picture, gene correlations are still not there. The new isoforms, the new flavours of CDKL5 are extremely interesting, and it remains to be seen what their functional importance is, and it remains to be seen what the links between CDKL5 and MECP2 are in terms of the effect on the nature of the disease and its progression. So there are lots of questions. The mouse model is a great step forward, and you should pat yourselves on the back for being associated with the development of the mouse model. And I'd just like to acknowledge my funding sources along the way. And I have to say that most of my funding has come from support groups and organisations rather than from government funding. And many of us who want to see advances happen would not have that happen without the support of organisations such as yours. So on that note, I'd be happy to take any questions if anybody has any. Or if there's time.
Give it a few minutes for questions.
Yeah.
You showed in the video some relationships that, with the thicker lines between the two different diseases. I noticed ARX was one. That's X-linked infantile spasms.
Right. Yeah.
And then what were some of the other ones? What did those stand for?
So DNMT1 is methyltransferase, and that too has been associated with MECP2. MECP2 regulates its function, and so there's a potential link. And there's been some study that has shown that CDKL5 interacts with that gene or that protein as well. UBE3A has been associated with Angelman syndrome, so mutations in that cause Angelman syndrome. And there's strongish data that links MECP2 with that, and not so much data with CDKL5. And then this one here is Netrin G1, which is another gene that has been associated with MECP2 as well. This one, I'm not sure, I can't remember what that one is. And these other ones are more distantly related or interacting with CDKL5, so possible lesser importance. But this is still early days, and as people are able to play with the mouse model and with IPS cells and non-IPS cells, we're going to get a more complex and hopefully more confident picture of which are the interacting genes there.
Those other two out there, sodium channel,
no, sodium channels are usually SCNs. These are SCNs.
Okay.
So I'd have to go back and look at what they do.
My daughter kind of has a unique situation. She has a complete deletion and a little bit of the gene before and after, but she was never diagnosed with infantile spasm. She didn't have her first diagnosed seizure until for her second birthday. She's progressing pretty well. She's walking. So I just wanted, you had mentioned that.
Well, that's great, firstly. Probably in that instance, what's playing a role in perhaps making her problems less severe than you might have expected, having had the whole gene knocked out, is that if you were to look at exon activation in the brain, you would probably find that it's skewed such that in many or the majority of the cells, the important regions in the brain, the normal version of the gene is the one that's switched on rather than the deleted one. So that's having a protective effect. That would be my guess in terms of the explanation for that. I mean, there's no easy way to prove that because that would require brain biopsies to be done. Of course, nobody's going to do a brain biopsy to look at exon activation, but that would be my guess in terms of why potentially she doesn't have as severe a clinical picture as you might expect.
Can you have